Division of functions. The quotient of two functions f of x and g of x is denoted by f over g of x, and this quotient is defined as f over g of x is equal to f of x over g of x. This means if we are asked to divide functions, we simply divide the two expressions. Let's have example 1. Find f over g of x when f of x is equal to 2x plus 4 and g of x is equal to x plus 2. Let's substitute the two expressions. We have the expression for f of x is 2x plus 4, while the expression for g of x is x plus 2. Now, when we divide functions, as you can see, this is a rational expression. And we are just going to simplify this expression by simply looking for the common factors of the numerator and the denominator. So let's do that. Again, we look for the common factors if there are any, if there is any common factor. And to do that, we have to factor out our numerator and factor out our denominator if possible. In this case, the numerator is factorable while the denominator cannot be. So let's try to factor out our numerator. We have 2x plus 4. We have a common monomial factor, which is 2, multiplied by 2x divided by 2 is x, plus 4 divided by 2 is 2. There you have it. No? We have 2 times x plus 2 is the factored form of 2x plus 4. Let's check. 2 times x is 2x plus 2 times 2 is 4. That's correct. Then we have our denominator x plus 2. So as you can see, we have a common factor. The factor x plus 2. So x plus 2 in the numerator and x plus 2 in the denominator. To simplify this, we cancel them out because they are equal to 1. X plus 2 over x plus 2 is equal to 1. Thus, we will have 2 as the answer. So cancel out x plus 2 is 1, and then what remains is the common monomial factor, which is 2. And writing it down, we have the quotient between f of x and g of x is 2. Okay, so the quotient between f of x and g of x, or f of x over g of x, is 2. What did we do? We factor out the numerator to look for the common monomial factor, the common factor, and we found it that it's x plus 2. Over x plus 2 is 1. What remains is the common monomial factor, which is 2. Thus, f over g of x is equal to 2. Again, we factor out to simplify our expression. Let's have example number 2. Find over f over g of x when f of x is equal to 3 and g of x is equal to 6x squared plus 3x minus 12. So let's substitute in our expression. Equation here, that is, what's the f of x? That's 3. While our g of x is a trinomial, and we can just copy and paste it. So we have 3 over 6x squared plus 3x minus 12. Again, we will just be dividing. No? Each term in the denominator will be just divided by 3 to simplify this expression. So we have equals what happens to 3 here? What happens to 3 here? It will just be equal to 1. Because 3 divided by 3 is 1. And 6x squared divided by 3 is 2. We have 2 copy x squared. No? 2x squared. 2x squared. Then plus 3 divided by 3 is 1. Then remains x. We have x minus 12 divided by 3 is negative 4. So there you have it. We have divide by 3. We have a common monomial factor, 3. So that is 3. 6x squared divided by 3 is 2x squared. 3x divided by 3 is x, and negative 12 divided by 3 is negative 4. But this is now the quotient of f of x and g of x. This is the quotient of f of x and g of x. But let me show you further how did I get this, no? Because we can write it down as still a common monomial factor and look for the common monomial factor here. See? And that is 3 multiplied by this expression. Okay? See? Let me show you again. Okay? Now, that is 3 over 3 times 2x squared plus x minus 4. So we factored out our denominator with a common monomial factor of 3. 3 times 2x squared is 6x squared, 3 times x is 3x, 3 times negative 4 is negative 12. Thus, the common monomial factor is 3. And we cancel out. 3 over 3 is 1. Thus, we have our quotient 1 over 2x squared plus x minus 4. So let me write it down. That is equal to, we have f over g of x. F over g of x is equal to this expression 1 over 2x squared plus x minus 4. So as you can see, we again looked for the common monomial factor of the denominator expression. We have 3. We factor it out using the common monomial factor 3. And then we cancel out 3 over 3, that is equal to 1. Then we have the quotient 1. Take note, 1 or 3 did not just disappear. It is replaced by 1 because 3 divided by 3 is 1. So the numerator is 1 over the remaining expression, which is 2x squared plus x minus 4. This is the quotient of our f of x and g of x. Let us have example 3. Find f over g of x when f of x is equal to 2x cubed minus 6x squared plus 8x, and the g of x is 2x. Now in this case, our g of x has a variable. Let's do this. It will help us, it will require us to apply our skills in dividing polynomials with variables. The loss of exponent. We have our f of x is this expression, while our g of x is 2x. Okay. Now, another way of doing this is simply dividing each term of the numerator by the denominator. So we can have it 2x cubed divided by 2x minus 6x squared divided by 2x plus 8x over 2x. And then the quotient would be, okay, let me show you how is it done for you to better understand this. Okay. Then we have again, each term of the numerator will be divided by the denominator, which is 2x. That is 2x cubed, 2x cubed divided by our denominator 2x. Again, then that is minus our second term 6x squared, negative 6x squared, again divided by 2x, and plus 8x will also be divided by our denominator 2x. So this is this is how it looks when we do it step by step now. Okay, so 2x cubed divided by 2x, 2 divided by 2 is 1, x cubed divided by x. When we divide same variables, we simply subtract the exponents, right? And then x cubed divided by x, that is 3 minus 1, and that's equal to 2. That's x squared. So there you have it, x squared. 2 divided by 2 is 1, minus 6 divided by 2 is 3. we divide also the numerical coefficients, and then x squared divided by x, that is x, 2 minus 1 is x. So 2 minus 1 is 1, then we have x, plus 8x divided by 2x, 8 divided by 2 is 4, and then x, 1 minus 1 is 0, x to the 0 is 1. So the quotient is x squared minus 3x plus 4. When f of x is divided by x squared, when f of x is divided by g of x, the quotient is x squared minus 3x plus 4. How did we do it? So each term of the numerator was divided by the denominator. That is 2x cubed divided by 2x minus 6x squared divided by 2x plus 8x divided by 2x. So we applied the our competencies and skills in dividing polynomials, especially the loss of exponent, which is the subtraction of, when we divide expressions of the same exponent of the same variable, we subtract the exponents. That is x cubed divided by x, that is x cubed minus 1, that is x squared minus 1 is x, and then x minus x to the 1 minus 1 is 0, and x to the 0 is 1. So we have 2 divided by 2 is 1, 6 divided by 2 is 3, and 8 divided by 2 is 4. This is the quotient. Let us have example 4. Example 4, when f of x is equal to x minus 2 and g of x is equal to x squared plus 2x minus 8. Now in this case, we have to do factoring quadratic expressions. Okay, so again, we will still do the factoring, just like in the first two examples. We factored out our numerator and denominator to look for the common factors and cancel them out to simplify our expression. Our g of x is this quadratic expression, x squared plus 2x minus 8. Okay, so let's look for the common factor. Let's see if we can cancel out x minus 2, the numerator, if it's a factor of our denominator x squared plus 2x minus 8. Now, how do we factor out quadratic equation? So we look for the factors. No? Factor out x, we have x, then another one is also x, and then pair it with the factor of our constant, wherein when added, it will give us positive 2. So look for two factors or factors of the constant negative 8 that when added, it will give us positive 2. It is 4 and negative 2, right? We have plus 2. And it's minus 2 rather. X minus 2 and positive 4. So as you can see, the factors of our constant negative 8 that when added will give us positive 2 are negative 2 and 4. When we add 4 and negative 2, we got 2, not the middle term. We got the middle coefficient. That is, thus we have now the factors of our quadratic expression, x squared plus 2x minus 8, which are x minus 2 and x plus 4. So as you can see, x minus 2 is also a common factor in this case. Thus, we cancel it out, and we have our answer, which is cancel out x minus 2. Again, when we cancel out x minus 2, it does not disappear. It simply means x minus 2 over x minus 2 is 1. So we still have a numerator which is 1. We still have a numerator which is 1. Okay? So 1 over the remaining factor of our denominator, which is x plus 4. So as you can see it, again, we cancel out x minus 2 because x minus 2 divided by x minus 2 is 1. X minus 2 in the numerator does not disappear. It is 1 over x plus 4. Thus, we have the quotient of f of x, or f of x, f over g of x is equal to 1 over x plus 4. What did we do? We factored out our denominator. We factored out our denominator to see whether we can cancel out x minus 2. And yes, we are successful. We have canceled out x minus 2. And again, x minus 2 here did not disappear. it is 1. We have a numerator 1 over x plus 4, which is the remaining factor of our denominator expression. So let's have example number 5. Example number 5 is still, it still involves quadratic expression. So substituting, we have our f of x again is 2x squared minus 5x plus 3. While our g of x is 4x squared minus 9. So this one is somewhat challenging. Where are we now? Okay, so we factor out again to see if there are any common factors to simplify our expression. Now, 2x squared, our numerator 2x squared minus 5x plus 3. When factored out, we have the factors 2x minus 3 and x minus 1. So let's check. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Negative 3 times x, negative 3x. And negative 3x plus negative 2x is negative 5x. And negative 3 times negative 1 is positive 3. So we have the correct factors of our numerator expression. And let's have this denominator. Denominator is the difference of two squares. Difference of two squares, we simply, the factors are the sum and difference of the square root. The square roots of the first term and the second term. So the square root of 4x squared is 2x. While the square root of 9 is 3. We can have the sum and difference of two terms. So it can be written as, see? So 4x squared minus 9 is the factor, it can be factored out as the sum and difference of two terms. So it's sum of 2x and 3 and difference of 2x and 3. So we simply get the square root of our first term and the square root of our last term. So we have 2x plus 3 and 2x minus 3. So as you can see, there is a common factor which is 2x minus 3. We cancel out 2x minus 3, and then what remains in our expression are the remaining factors. No? Cancel out 2x minus 3, cancel out 2x minus 3. Thus, we have in the numerator, what's left is x minus 1. In the denominator, what's left is 2x plus 3. So as you can see, let me denote this. We have now the quotient or f over g of x is equal to this expression, x minus 1 all over 2x plus 3. So what did we do? We factor out our numerator, 2x squared minus 5x plus 3, and the factors are 2x minus 3 and x minus 1. And then the denominator for x squared minus 9 was factored out. The factors are 2x plus 3 and 2x minus 3. It can be expressed as a sum and difference of two terms. Na? And then we have found out that we have a common factor, which is 2x minus 3. We cancel them out, and what remains in the numerator is the factor x minus 1, and in the denominator, 2x plus 3. Thus, when f of x is divided by g of x, the quotient is x minus 1 all over 2x plus 3. Let us have the second to the last example. Find f over g of x when f of x is equal to x cubed plus 5x squared plus 2x minus 8, and g of x is equal to x plus 2. Now, in this case, we can have the long division process, or we can just have the synthetic division. I hope you've watched my video on synthetic division. But before that, we will first substitute the expressions in our equation. We have f of x again is x cubed plus 5x squared plus 2x minus 8, and then g of x is simply x plus 2. Now, let's divide this using the synthetic division. Okay? So in the synthetic division, we need, again, the numerical coefficients and then the value of x here. So let's have our board. So again, let's write it like this. And x plus 2, then when equated to 0, it will give us x equals negative 2. So the number here is negative 2. Okay? So x plus 2, the divisor, x plus 2, when equated to 0 is negative 2. We have x equals negative 2, and we write it here. No? And then we write down our coefficients, numerical coefficients. Let's look first if we have a complete term. 3, 2, 1, and then the constant. There we have it. 1, the coefficients are 1, 5, 2, and negative 8. Again, 1, 5, 2, and negative 8. We have 1, 5, 2, and negative 8. Okay, so this is synthetic division. Bring down the leading coefficient 1, multiply it by our divisor, or the number here, negative 2, then we have negative 2. And add, no? 5 plus negative 2 is positive 3. Again, multiply again, 3 plus negative 2 is negative 6. And then 2 plus negative 6 is negative 4. And we have negative 4 plus negative 2 is positive 8. And negative 8 plus 8 is 0. Okay? So again, this is the remainder, while these are the coefficients of our quotient. So in writing down our quotient, we will be using these coefficients together with the signs. And of course, again, in writing our quotient, when we use synthetic division, we write our quotient starting with 1 degree lower than our dividend. In this case, our dividend is x cubed. So it should be x squared. 1, then we write it x squared plus 3x, and then the constant minus 4. So x squared plus 3x minus 4 is the quotient when f of x is divided by g of x using synthetic division. So we write it down. We denote this as the quotient of f of x and g of x is equal to simply our expression. We have x squared plus 3x minus 4. How did we arrive at this quotient? We used the synthetic division method because we have a polynomial already. Okay? So let's have the last example. Find f over g of x when f of x is equal to 2x to the fourth minus 5x cubed minus 11x squared plus 20x plus 12, and g of x is equal to x minus 3. So again, let's substitute this before we use the synthetic division again to solve for the quotient of these two functions. For f of x, we have this expression, and g of x is simply x minus 3. Okay, so again, let's use the synthetic division. Now, again, in using the synthetic division, we need the number here and then the coefficients. And x minus 3 when equated to 0 is x minus 3 equals 0, and then x is equal to 3. The value for x is 3. So we have it here, 3. Okay? And then we look for the coefficients. Are the terms complete? Yes, x to the fourth, cube, squared, x, 1. Okay, then you have the coefficients 2, negative 5, negative 11. We have 2, negative 5, negative 11, 20, and then the constant, which is 12. Okay, let's extend this. Are we right? 2, negative 5, negative 11, 20, and 12. Okay, and then we have our divisor 3. Okay, x minus 3 equals 0, x equals 3. Thus, let's bring down our first two coefficient. First coefficient, 2. 2 multiplied by 3, which is 6. Add, we have 1 times 3 is 3. Negative 11 plus 3 is negative 8 times 3 is negative 24 plus 20 is negative 4, and then times 3 again, that's negative 12, and then the remainder is 0. So this is the remainder 0, the constant, and then the coefficients. Let's write it down. Again, 2, and then the degree is 1 degree lower than our dividend. We have x to the fourth, then this is x cubed, minus this is x squared. No need to write 1, minus 8x, and then the constant minus 4. Thus, the quotient when f of x is divided by g of x is 2x cubed minus 8x squared minus 8x minus 4. Let's write it down here. We have f of x equals 2x cubed, 2x cubed minus x squared minus x squared minus 8x minus 4. When f of x is divided by our g of x, which is x minus 3, the quotient is 2x cubed minus 8x squared minus 8x minus 4. What did we do? So in this case, if we have a polynomial function, a polynomial expression in the numerator, and then we have a linear equation, linear expression in the denominator where x, the exponent of x is 1, we can use the synthetic division because it is shorter. This is division of functions.